Good evening to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, KR Bangalore. Today I am going to discuss about 10th session of Chemistry and so that is the 6th session of Gaseous State, which belongs to first semester BSc affiliated to Bangalore North University. In this session, I have to discuss about experimental determination of critical constants by Amagat's mean density method and solving some problems. The main objectives of these sessions are experimental determination of critical constants, that is a VC by Amagat's mean density method. Then solving some problems on critical constants. This we have to discuss in this session one by one. Then after completion of this session, you will be come to know that is a how to determine that is a critical volume by Amagat mean density method and how to solve some problems on the critical constant, that is a critical temperature, critical volume and critical pressure, that you have to able to solve. You have already you will be known after this completion of session. Now before commencement of this session, you have already know about limitations of Cagnard-de Latour method, then expressions of TC, VC and TC A and B. These are the constants, these are the values, expressions and expressions of each terms you have already known before commencement of, before discussing of this session. Now coming to experimental determination of critical constant of VC by Amagat mean density method. Now here this method, the most accurate method of determining the critical volume was given by Amagat, because the earlier the Cagnard-de Latour method, it is failed to determine the critical volume. Therefore, that can be done by using a Amagat method. Amagat, he determined that is accurately critical volume. It consists of measuring the densities of a liquid and its vapor at number of temperatures near the critical point and plotting these two densities against the temperature. When the two curves are representing the densities of the liquid and the vapor thus drawn are extended, they naturally meet at the critical temperature, because here the density of the liquid and vapors becomes identical. Here in this simple method is there, the density, the temperature versus density measuring at near to the critical point, because at critical point the density of the liquid and gases or its vapors are identical and they will be meet, and from that we can calculate the critical volume of the gas. Now here the graph is says that it is a critical temperature and this is the density. As the density increases, the vapors, as the temperature increases, the density increases, the at temperature the vapors also increases. The as the temperature increases, the density of the vapors increases, and similarly as the temperature increases, the density of the liquids decreases. Here therefore it is series of that is curve will be a produces, and here from this we will get that is a different densities we can be determined by rising the temperature near to the critical temperature. And this curve plotting this, and from this curve the extended we will meet at a particular point, that is the C, and from that we drawn that is straight line curve, that is a CD. We will get that is a density here. Density we will be get, and a density which is nothing but the both having a vapor density as well as liquid, it is identical at the C point, and from that we can calculate that is a volume of the liquid, that is a critical volume of the gas. The mean values of the densities are then plotted against the various temperature where straight line CD is obtained, which will be obviously pass through the critical temperature, which will be given by the point where this line will be cut the curve AB shown in figure. Just simply we are drawing this curve, we will getting this, and this is the, because the vapor pressure, the density of the vapors increases and density of the liquid decreases, and they meet at certain point where at that point the density of vapor as well as liquid will be identical. At that point, from that we are draw that is a straight line curve, and it will get at a axis we will get that is a density. By knowing the density and mass of the liquid, molar mass of the liquid or gas, from that we can calculate the molar volume by using the formula. Therefore, the density of the corresponding C point drawn critical density. It is called as a actually critical density. Critical density. CD is called as a critical density. Here we will get that is that value. Now the critical volume is obtained by dividing the molecular mass of the liquid by critical density. Therefore, critical volume is equal to molar mass divided by critical density of that liquid. We will get that is a Vc is equal to M divided by Dc. There Dc is nothing but critical density, M is nothing but molar mass, and Vc is nothing but critical volume. By using this method, we can calculate accurately critical volume. Now coming to that is solving some problems on the critical that is constants. I will solve that is only two problems. First problem goes to calculate the critical constants of oxygen gas given van der Waals constants. A is equal to 0.1378 Newton meter to the power of 4 per mole square. B is nothing but 3.18 into 10 raised to minus 5 cubic meter per mole. Then R is nothing but 8.314 joules per Kelvin per mole. From that you have to calculate that is a critical constant of oxygen gas, that is a Tc, Vc and Pc we have to calculate. So therefore solution for this question is given that A is equal to this much value, B is equal to this much value, and R is nothing but 8.314 joules per Kelvin per mole. Therefore Pc is equal to what that you have to find out. Vc is equal to question mark that you have to calculate, and Tc we have to calculate. We know that the value that is Pc from the earlier sessions, we know that Pc is equal to A divided by 27B square. Simply substitute that is value of A and B in this equation. We can solve this. We can get that is a Pc value. Therefore, A is nothing but 0.1378 Newton meter to the power of 4 mole per square divided by 27 into B value 3.18 into 10 raised to minus 5 meter square, that is cubic meter per mole square. Then after that is simplifying, we will get this value. Then Pc is equal to, after we are writing, no, this is cancelling, that is a Newton remains as it is. The this should be a meter to the power of 6, no, that will becomes that is a per meter square, per mole square get cancelled. Therefore we will get that is a 50.47 into 10 raised to minus 5 Newton meter square. Again from that we can calculate that is a Vc. Vc is equal to, the value of Vc is equal to 3B. Therefore 3 into B value is nothing but 3.18 into 10 raised to minus 5 meter cube per mole. This can be written as, after multiplying, 9.54 into 10 raised to, here into actually here into 10 raised to minus 5 meter cube per mole. Then similarly we have to calculate Tc is equal to 8A divided by 27 Rb. Now substitute the value of that is A and B are from the above value. Therefore 8 into value of A is nothing but 0.1378 Newton meter to the power of 4 per mole square divided by 27. B that is R is nothing but 8.314 joules per Kelvin per mole into that is B is nothing but 3.18 into 10 raised to minus 5 meter square per mole. Then after calculation we will get that is a 154.4 Kelvin, where actually newtons you have to nm is you have to put that is joule joule can be replaced by nm. Therefore nm is equal to joule, or in the joule in the equation will be there. In place of joule you have to write that is a Newton meter. This is the solution for first problem. Then we have to go to that is a second problem. The second problem it say that the critical constants of HCl are Tc is equal to 325 Kelvin and Vc is equal to 8.10 into 10 raised to minus 5 meter cube per mole. Calculate the van der Waals constant for gas. Now solution for this question, the given that Tc is equal to 325 Kelvin, Vc is equal to 8.10 into 10 raised to minus 5 cubic meter per mole. Then Pc is equal to what, and A and B what that is the what are they, that we have to determine. We know that B is equal to Vc divided by 3. You already know from previous session B is equal to Vc divided by 3. Therefore Vc is nothing but 8.10 into 10 raised to minus 5 meter cubic meter per mole divided by 3. After dividing we will get that is a 2.7 into 10 raised to minus 5 meter cube per mole. Then similarly Tc is equal to 8A divided by 27 Rb. Okay, Rb, and this can be written as A is equal to from that we can calculate B is here obtained. From that we can calculate A is equal to 27 RBTC divided by 8. Substitute the value of RBTC from in this equation. We will get that is a 27 R means that is 8.314 joules per Kelvin per mole into B means that is a 2.7 into 10 raised to minus 5 meter cube per mole into Tc is nothing but 325 Kelvin divided by 8. After dividing we will get that is A value is nothing but 0.24622 into 10 raised to that is a into that is Newton meter 4 to the power of 4 per mole, because here again here joule will be there, no joule, in joule place you have to write that is a nm, that is a Newton meter is called that is a joule. Now similarly by knowing that is value of A and B we can calculate finally that is a Pc. Therefore A is nothing but 0.24622 into that is a n newtons meter to the power of 4 per mole square divided by 27 2.7 into 10 raised to minus 5 cubic meter per mole to the power of square. Then after that is a simplifying this will be get, and after simplifying we will get that is a 125.09 into 10 raised to minus 5 Newton per meter square. This is called as a critical pressure. Therefore so far we have discussed in this session the experimental determination of a critical volume by Amagat's mean density method and solved some problems on critical constants. Now you have very well known, understand this session. Therefore I will ask some question, please answer them. The first question goes to Amagat mean density method is used to determine First one is critical pressure, critical temperature, critical volume, and D is nothing but none of these. Correct. Choose the correct option for this question. I will give 10 seconds for you people. The C option is the correct option for this question, because critical volume is determined by using a Amagat mean density method. Okay, Amagat mean density method is used to determine that is a critical volume only, but not critical pressure and critical temperature. Therefore, C option is the right answer for this question. Then second question, for determination of critical volume, graph is plotted, critical pressure against critical volume. C option, critical temperature against density. Then C option, critical temperature against critical volume. Then D option, none of these. Just I will give 10 seconds for you people. You have to select correct option. The correct answer for this question is, that is a B. B option, critical temperature against density. The graph is plotted, and to get that is a for the vapors, that is the liquid, and the density of the vapors, the meet at a particular time, particular point, and from that point it critical density can be calculated. By critical density knowing, we can calculate that is a critical volume. Therefore, that is a B option is the right answer for this question. Then third question, the value of J. Value of J is nothing but A option Newton meter, B option Newton per meter, then C option meter per Newton, and D option none of these. I will give just 10 seconds for you people. You have to choose the correct option. The A option is the right option for value of J. Value of J is nothing but Newton meter. Newton meter is nothing but the correct value of that is J. Okay, now coming to the fourth question. The ratio of mass by density is called. The ratio of mass by density is called volume, or B option pressure, C option temperature, and D option is none of these. I will give just 10 seconds for you people. You have to say correct option. The A option is the correct option. Mass by density is nothing but volume. Is the volume. Therefore, mass by volume is called as a that is a mass by density. D is nothing but mass by density, or density is nothing but mass by mass per unit volume. Therefore, volume is equal to mass by density is the right option. Therefore, A is the right option for this question. Therefore, this completes this session. For preparation of this session, I used these reference books, and thank you.